Welcome everybody, this is Mr. Navarrete and today I'll be going over the Kinetics Homework number 4. So let's get started. For number 1 it asks, what is a rate law? Our rate law is an equation that connects our chemical reaction rate to the concentration of our reactants. It's just an algebraic equation that lets us connect how fast our reaction is going to happen to the concentration that we currently have of our reactants. 2 asks, what is a rate constant? And our rate constant is very much like R with our ideal gas law. It is a proportionality constant. And all it does is it allows us to relate our rate with our concentration. 3 asks, how do you determine this rate law for a specific reaction? And all of this is done experimentally. They measure the rate of a reaction at specific concentrations, and then they keep doing it over and over and over and over until we're able to create a law that works for that specific reaction. 4 asks, what does the rate constant tell us about our reaction? And that tells us our rate of our reaction, but at a specific temperature. Our rate constant is going to continuously change depending on our temperature. While our rate law is going to stay the same, our rate constant is going to change depending on our temperature. 5 says, consider the following rate law. What is the order of the reaction with respect to nitrogen monoxide, oxygen, and the overall reaction? So let's look at nitrogen monoxide. On our rate law, it has that invisible power of 1. So to find the order of our reaction, since it has that invisible 1, we say that it's first order with respect to nitrogen monoxide. We can follow that same trend to find the order of our reaction for oxygen. Looking at our power, it's 2, so it'll be second order. Now to find our overall order of our reaction, we can just add our together. We have a 1 and a 2, so our overall order for the reaction is going to be third order. 6 asks, what is a reaction mechanism? And simply put, a mechanism tells us the steps that take place in a reaction at a molecular level. For those of us that are going to take organic chemistry, we do a lot of mechanisms, drawing a lot of these steps to show how is it that our reactions happen and more importantly, why. Our reaction mechanism allows us to find a lot of very useful information, allowing us to have a deeper understanding of our chemical reaction. 7 asks, what is meant by the rate determining step? Our rate determining step is a step in our reaction that determines the rate of our overall reaction. Pretty straightforward definition. 8 asks, what is an intermediate? And an intermediate is a molecule that is created in one step, but then is immediately used up in the next. Similarly to cooking or in baking, you are creating many intermediates that eventually are going to be used up in your next step of the recipe. 9 asks what a transition state is. And simply put, it's a very short-lived molecule orientation. And these transition states are usually or have the highest amount of potential energy. Looking at an energy versus time graph, our transition state would be at the very, very peak. Now let's look at an environmental concern and the depletion of ozone in Earth's atmosphere. We are presented with the proposed mechanism, and it asks to write our balance equation for the overall reaction. Very similar to how we would do when writing our net ionic equations, we have to get rid of all the intermediates. In step 1, we create hypochlorite, and in step 2, we use up hypochlorite. So we can get rid of our hypochlorite. And in step 1, we use our chlorine, but we also create chlorine. So those aren't going to be part of our overall reaction. Getting rid of those intermediates, we can see that our overall reaction is going to be ozone plus oxygen will give us oxygen gas. Now that we have our overall reaction, we can start balancing it, and you can check your coefficients with mine. All I did was add a 2 to my oxygen gas. 11 asks to explain why chlorine is a catalyst in this mechanism. What causes this reaction to start is my chlorine. Without it, our ozone wouldn't deplete. Chlorine is what starts our reaction. 12 asks to explain why hypochlorite is an intermediate in this mechanism. Looking at my mechanism, it's created in step 1. We see that as a product between ozone and chlorine. But in step 2, it's immediately consumed again with our oxygen gas. It is created, but then immediately used up in the next step. Now we have to consider this following mechanism. And we have to identify any species that's an intermediate. I'm going to compare step 1 and step 2. What intermediates do I immediately see? Well, we create C, and then we immediately use it up. So C is going to be an intermediate. Now let's look at step 2. In step 2, we create D, but then in step 3, we also immediately use it. So 2 intermediates are going to be C and D. Now we have to identify the catalyst. And looking at step 1, my catalyst is going to be B. This reaction would not occur without the presence of B. Our other catalyst, if we look at step 3, this reaction would not occur without the presence of F. It's not something that we're already creating, it's something that's totally new. F would be our other catalyst. Now we have to identify the rate determining step. So in this case, we are told that our first step is the slowest one. So step 1 is going to be our rate determining step. It doesn't matter how fast the other ones go, because our slow one is ultimately going to dictate the rate of our reaction. Lastly, we have to write an overall equation for our reaction. We're only going to focus on what is being used up and what new things are being made. Looking at all 3 steps, well, our A, while it's being used, it's also being made in step 3. C is being created in step 1, but it's also being used up in step 2. So we can get rid of that one. And D is being created in step 2, but being used up in step 3. Adding everything that is left over, we end up with 2B plus F will give us 2E. And that's it. If you have any questions, don't forget to message myself or Mr. Morgan on Schoology. Other than that, stay safe, and I'll see y'all next time.